Okay, so this video is about manufacturing aids. Okay, there are a range of different manufacturing aids, but the ones we're going to discuss today are templates, jigs, molds, formers, and dies. Okay, so these 5 manufacturing aids, I'm going to kind of define these, give you a bit of a description of what they are, and some ideas of some examples or some applications of how they might be used. Okay, so if we talk about templates first, okay. As with most of these manufacturing aids, what we use manufacturing aids for are to increase repeatability and therefore accuracy of each item to ensure that all products are exactly the same. Now a template, we might use it, for example, to draw around. Okay, so if we was marking out a product that was going to be hand cut or something like that in resistant materials, we might make a template. Now a template is normally made out of a fairly rigid material that is not going to be damaged too much, because obviously if we made a template out of, say, paper or very thin card, by the time we've drawn around it 2 or 3 times, we'd find the edges would be wearing and the shape would deviate. The shape, the size, the parameters of it would be different each time we drew around it, and therefore it would no longer be useful. The 10th item would not therefore be as accurate as the first. So we want to make our templates out of a fairly rigid material so it doesn't get damaged with each use. Okay, and templates can be used across any different specialist area as well. So in textiles, for example, we could use a template to draw around fabric pieces. In food tech, we might use a template to draw out maybe a decoration for the top of a cake, such as a bow or a flower or something like that. We might use those if we was going to hand cut around a template. Now the second on our list is jigs. Now jigs are used to control the movement or placement or even the direction of another tool. Now this is quite difficult to try and explain, but for example, if I wanted to repeat a drilling process, I wanted to repeat maybe drilling 20 holes on a piece of mild steel, okay, what I might use is a piece of harder steel that's already been pre-drilled with 20 holes in the correct position. I could then lay this over an existing piece of material that I wanted to drill, and it would very quickly and easily line up all of those holes so that I could just use the drill and follow through the existing holes to ensure all of these were in the right places. Okay, in terms of textiles, the use of tailor's tacks, for example, is another way you could argue might be an example of a sort of a jig, okay, because it ensures that when we stitch to a certain point that we know where we're going to stop and where we're going to place those tools, in which case the sewing machine in this particular example. Now third on the list is molds. Okay, so molds, if we think about food technology, for example, are very, very useful because we can pour a liquid material into a mold, and when it cools and solidifies we can take that out, and again it's a very repeatable process. So if you think about certain materials such as jelly or chocolate, okay, these are used as mold in the molding process quite frequently, where we just pour those materials in, and upon them hardening we can take the mold off, and again, like with templates, it will be made of a rigid enough material that the mold would not disintegrate or degrade each time we molded it. One example of a material that we might make a mold from is high impact polystyrene, or polystyrene in resistant materials, and one way we make molds is through the vacuum forming process. So we could quite easily vacuum form a piece of food safe plastic in resistant materials, take it down to food technology, and then use it for chocolate molding or jelly molding, as we discussed before. Now the way we make the mold is in the vacuum forming process is we would use a former. Now a former is normally used to control the way a piece of material will be formed or shaped. Okay, so in resistant materials, vacuum forming, we might make a former out of a very smooth material such as MDF or gelutong or chemiwood, okay, and we can heat up the thermoplastic and use the vacuum former to form over the shape, creating a mold for us. Another use of formers is in the drape molding process. So again, if we took a piece of thermoplastic, perhaps a piece of acrylic, and we wanted to bend it into an interesting shape, but we wanted to bend this multiple occasions, we would use a former to ensure that all our formed pieces of plastic are exactly the same. We can heat the plastic up, drape it over a former, and then it will take on the shape. Now often The former may come in two or multiple parts, so we might have a male part of the former, which is the bit that sticks out effectively, and the female former, which is the bit that covers over the top and forms the thing more accurately. Okay. Now formers can also be used in other areas as well. So if we think about the food technology which we was discussing earlier on, you may wish, for example, to form chocolate over the back of a bowl, or maybe candied sugar over a bowl to create a decorative effect. And again, if we're producing perhaps 10, 15, 20 cakes and we want that same sort of decorative effect to be placed, we would obviously use the former, which would be the same bowl, or we may even produce a bowl specifically for forming over. Okay, the final manufacturing or production aid that we're going to discuss is dies. Okay, so dies are not the things that we're going to throw in a game in this particular case. They are effectively shapes. Okay, now they are shapes that can be used to cut repeatably, and they are often shapes that can be used in an extrusion process. So if we talk about extrusion, the best way to think about this is perhaps think about a toothpaste container. Now if my toothpaste container is filled up with toothpaste and I squeeze one end, I apply pressure to the toothpaste, it forces it out of the die, which is basically the nozzle. So in a normal toothpaste tube, the nozzle is circular, and therefore I will get a circular extrusion coming through this circular die. If I change the shape of the nozzle of my toothpaste to a triangle, I would get a triangular extrusion. If I change it to a star, I would get a star-shaped extrusion, and so on and so forth. And some of you guys in your youth, you may have played with some of those Play-Doh factories where you put a piece of Play-Doh in the toy and squeeze it down, and all sorts of interesting extrusions come out to change the shape of hair, or to just produce interesting sort of forms that are a continuous extrusion of a 2D profile. Okay, one other example of dies, which is you've used very frequently probably in the food production area, is for use in cookie cutters, or die cutters as you would formally call them, whereby we have a shape of perhaps a star or a biscuit shape, for example, and we can push it down onto a softer material such as dough or biscuit mixture, and by placing this several times over the biscuit mixture, we will produce a series of items that are all exactly the same. So the manufacturing aids we've covered today are templates, jigs, molds, formers and dies.